Find peak element. A peak element is an element that is strictly greater than its neighbors. Given a zero-indexed array, integer array nums, find a peak element and return its index. If the array contains multiple peaks, return the index to any of the peaks. You may imagine that so the edges instantly count. In other words, an element is always considered to be strictly greater than a neighbor that is outside the array. Oh, I see. Well, that's actually not okay. So it's saying these two are the left of the zero index and right of the last index, which isn't really true because this would return the last index, and they're both negative infinity. Okay, cool. You must write an algorithm that runs in log n time. Okay, so if we have O log n, okay, so this is in the binary search category. I don't see how, but maybe if I dig, I'll find it. Well, let's think about it. We know we can make O(n) time. O(n) time is easy. And that's because you could just go through left to right and stop once you find a greater I think I got it. You go through left to right and stop once you find a peak. But here we go. I think that there's a simple truth of this. If something is not a peak, then there is a number to its side that is greater. That direction must eventually go back down because of the edges. Because of the edges. So we could say if you have 1, 2, 3, 1, and you're looking at 2, and you see 3 over here, then you say, okay, 3 is my new number. Because it must eventually go down. If it doesn't go down, then you'd have 4 over here. And you could say, well, then try the 4, and then it eventually must stop. Because even if it keeps going, 5 is a peak, because the outside of that is negative infinity. So since we need O log n, the problem that would be like n over 2, which is n. What we could do is we can instead say we can instead say go through it. Well, yeah, go for the middle, and then go in whatever direction has the peak. Well, it has a higher number. Because over here, there's no peak. There's no peak over here. But there could be a peak this way. And it could be 4, but it could also be the one beyond that. So it's just a binary search, but instead of saying like, oh, okay, is it less than or greater than the mid? It's is the neighbor greater than or equal to? There's the neighbor greater than. So that's how we do it. Binary search, but the key is which neighbor is greater. Okay? Cool. So L equals 0, L equals 0, say n equals length of nums. We'll say L equals 0, R equals length of nums. Do you want to do length of nums minus 1? I think we have to. Okay, so now we say while L is less than R, mid equals R plus L divided by 2. We wrap that up. For clarity's sake, it would work the same, I believe. Now we'll say if nums mid why don't we just say if length of nums equals 1? Where are the edge cases? Yeah. If length of nums equals 1, return 0. Because that way we know. Because the problem is we're playing with the neighbors here. But the neighbors think I'm selling dope. The neighbors, the problem is that we don't know if there is a neighbor. So what we'll do instead is say, okay. So the midpoint. The midpoint would default to the lower side. So we'll check to see if nums mid is less than. So we would default to the left side since it's floor division, meaning that there would probably be a neighbor to the right. So if nums mid, and there must be a neighbor because otherwise these two would be equal. Cool. Mid plus 1. Then L equals mid plus 1, because we know that mid is not the answer. So we might as well skip over it in our next search. Otherwise, that means that no. We can check is nums mid. I think actually is nums mid greater than, less than nums mid minus 1. And I think we should do some edge detection. So if mid is less than n minus 1 and if mid is greater than 0. So a little bit of edge detection. R equals mid minus 1. Else return mid. I think the neighbors think I'm selling dope. Cool. And then what do we do outside of that? Would we just return L? Because once they cross over, that must be the answer, because there has to be one answer. So we could just say return L or R. Woohoo! There we go. Great problem.